Okay, welcome to Chapter 9, Part 2. We've been talking about multivariate correlation, and we've been specifically talking about multiple regression. So what we're going to do today is we're going to talk about a couple of examples of multiple regression, and then we're going to discuss mediation and mediation analysis. So the first thing we need to talk about is an example. So this is some example data based off of what we were discussing last time. So let's say that we've got three different variables here. I've got time spent with friends, satisfaction with social life, and happiness. Let's say that I'm measuring time spent with friends in the number of hours you spend with your friends during 1 week. Satisfaction with social life is a scale, and happiness is also a scale. What kind of data do I have? These are three different continuous variables. Three different continuous variables. Now, if I want to look at all of them at the same time, then I have to use a specific kind of statistic. Now, specifically when I say all of them at the same time, what I'm saying is I think that both time spent with friends and your satisfaction with your social life, both of them together predict your happiness. What statistic am I going to use? I use a multiple regression because I've got one outcome, that is your happiness. Now, I'm not calling it a dependent variable because in this case we're measuring everything, but it's like a dependent variable. It's the outcome that we care about. So happiness is the outcome, and then time spent with friends and satisfaction with your social life are both predictors of your happiness. And I want to look at them together, not separately. I want to look at them together, and then after that, we'll look at them separately. So let's first look at the multiple regression and look at what the data looks like. So this is the actual data that you would get from a multiple regression. Here's the output of what a multiple regression looks like. If you remember last time we talked about R, okay? We talked about R, capital R, as a statistic. What does R tell us? R tells us the effect of both of them, time spent with friend and satisfaction, on your social life. Okay, so both of those together on your social life. Both of them together. Now, what's interesting about this is that we need to talk a little bit about how to look at the output for R. So you'll notice we have capital R right here. So capital R. This number, 0.985, is the combined effect of the two predictor variables on the outcome variable. All right? Well, wait a minute. What is this thing over here, this ANOVA that it's talking about? What's the ANOVA for? What is all that? Well, I don't know if you remember, but we have to modify. I don't know if you remember when we looked at the output for a lowercase r, which is a Pearson's R. When you look at the output, we had actually a t statistic, and that would the R was transformed into a T, and the T is the one that gave us the p-value. Well, in this case, that's what's going on. The capital R is transformed into an analysis of variance, which is an F statistic right here. And this is the p-value of that transformed F statistic right there. So, based off of that p-value, does both time spent with friends and satisfaction, do they combined predict happiness? Yes, they do, because this p-value is less than our alpha. P equals 0.005. We need that p to be less than 0.05, and it is. So we can conclude that those two are together predicting happiness. All right. Now, if you remember though, when we talked about multiple regression, we didn't just talk about capital R. We talked about beta as well. When you run a multiple regression, you'll get all of this and this. You'll get all of this. All of this information comes when you run a multiple regression. What does beta mean? Beta is the individual effect of each of the predictor variables on the outcome variable without the effect of the other one. So, for example, beta is the standardized one right here. So this is beta. Okay, this standardized one, that's beta. All right. This number right here is the coefficient telling us the influence of time spent with friends without any overlap of satisfaction with social life. Because if you think about it, the more time you spend with friends, you would assume that that would increase the satisfaction with your social life, right? So what this number, this beta is doing, is 1.462, is it's saying, hey, time spent with friends by itself, this is the influence that time spent with friends has on happiness. Conversely, and by the way, this is the p-value for that statistic. Conversely, let me go ahead and erase this x over here. This beta, put it right here, this beta is the influence of satisfaction with your social life on happiness without the influence of time spent with friends. Okay? Looking at these data, which one of these variables independently predicts your happiness? Only time spent with friends actually predicts your happiness. Because, look, the p-value is less than 0.05. P-value of 0.008, that's less than 0.05. But look right here, 0.096, that is greater than 0.05. So what this is saying is that time spent with friends is really the only thing that independently predicts your happiness. Satisfaction with your social life doesn't do that if you're taking out the influence of time spent with friends. Let's talk a little bit about terminology. Whenever we're talking about a correlation, we can't say that correlations cause something. So I'm not saying that time spent with friends causes you to be happy. That's not what we're saying because we just measured them. All right? But we can say that it predicts it. We can predict using a correlational study. We cannot show causality. So prediction or influences or is associated with, all of those are involved with correlation, and they indicate a certain amount of covariance. All right, the other thing is that with a multiple regression, sometimes we'll describe this as saying time spent with friends independently predicts happiness when controlling for satisfaction with your social life. Controlling for in this case means taking out the effect of, right? That's what that means. Statistically, that's being controlled for. It's not being controlled for in the study's design. It's statistically being controlled for. We take it out with mathematics instead of with the research design. Let's move on to another example. What you see here is the actual data from a study I did with one of my former students, Stephanie Jaime Luna, and she did a survey on bullying, okay? A survey on bullying. So the outcome, which you don't see here, the outcome is bullying behavior. She was interested in saying, hey, what contributes to somebody becoming a bully? That's what she was looking at, all right? How many predictors did she put in this multiple regression? How many predictors? She has 4 predictors. 1, 2, 3, 4. What she's saying is she wants to look at the effect of being a victim of bullying. That's the official victimization scale that you see right there. The effect of antisocial behavior, that's the antisocial scale that you see right there. The effect of drug use on becoming on bullying behavior, that's the official drug use that you see. And then friendship delinquency, that's how delinquent your friends are and whether or not, how delinquent your friends are in contributing to bullying behavior. Do those 4 predictors significantly predict bullying behavior? The answer is yes. This right here, 0.695, that R, is telling us that those 4 predictors, the ones that we discussed right here, these 4, that those 4 predictors predict bullying behavior. Now, is it significant? For that, we look down here at the ANOVA, and we're looking at this p-value right there. That p-value is less than 0.001. Our standard is 0.05, so we can statistically significantly say that those four factors, how much you've been victimized by other bullies, your antisocial, official drug use, and friendship delinquency, those four things together predict the outcome, which is how much of a bully you are. All right, let's get rid of that. And we'll look now at the betas. Of those four predictors, which one or ones actually predict bullying behavior? So of the four, which ones actually independently predict bullying behavior? All right, to look at this, we look for the betas. So the standardized ones, that's beta right here. So let's make sure that we got this. See if I can get it to go. There we go. These are betas. All right. What you'll see right here is official victimization. The beta for that is significant at 0.001. All right. By the way, the intercept, don't worry about that. That has to do with, this is a linear regression, so there's actually an intercept that's involved. You don't care about that, okay? The official victimization scale by itself does predict bullying behavior. That means that how much you are of a bully does predict whether or not how much you've been victimized by other bullies is going to predict how much you bully. That's what this says. In fact, if you look at this number is bigger than all the rest. It's saying that it is the biggest predictor, right? It has the most effect, the biggest effect size of any of those. What about antisocial? Well, antisocial is also less than 0.05. So yes, it also predicts it independently of everything else. What about drug use? Well, drug use, look at this. This p-value is 0.471. Even though drug use was together one of the four that together predicted bullying behavior, by itself, when you control for everything else, drug use does not significantly predict whether you're going to be a bully yourself. What about how delinquent your friends are? Well, look at that right there. That's less than 0.05. So of those four, how much you've been a victim of bullying, how antisocial you are, and your friendship delinquency, how delinquent your friends are, those three things, independent of the other ones, predict whether or not you're going to be a bully yourself. All right. We need to talk about mediation. What you see right here is an example of a mediated hypothesis. Mediated hypothesis says that the causality has to go through something else. Causality goes through something else. So what this is saying, let's assume that we had a survey and we measured how much time you spent with your friends, we measured how much social support you feel, and we measured how happy you are. All right? Now, remember, this is still a correlational study. What we're doing right now is still a correlational study. But we can get closer to the ideas of causality. Remember what we need to do for causality? We have to have covariance, temporal precedence, and have internal validity, right? We can get closer on those things using a mediation analysis, which is a combination of correlations and multiple regressions. So what this is saying is, hey, I think that time spent with friends and social support, I think those are correlated. If I was going to correlate just how much time you spent with your friends and how much social support you have, what statistic am I going to use? I'm going to use a Pearson's R. So this right here, this specific connection is going to be with a Pearson's R. Well, then likewise, social support on happiness, we can look at a Pearson's R. Okay? But the problem with that is that it doesn't do it independent of each other, right? It's not independently taking out the effect of time with friends or taking out the effect of social support. That's not what's happening. In fact, what we would do is we'd first run a Pearson's R not only with time with friends and social support, and then a separate one for social support and happiness. We would also have another one right here looking at this R, right? So whether time with friends also is correlated with happiness. So we would run 3 separate Pearson's R's for all the combinations. And if mediation is happening, then all of those should be significant. All right. Now we need to talk about mediation, because this, what we have right here, cannot tell us that time with friends has to go through social support in order to create happiness. Mediation means it's got to go through, right? Immediate means without anything in the way, right? Mediation means I've got something in the way, something in the middle. So what we're saying with this hypothesis is that time spent with friends causes more social support, and that causes happiness. So what we do in a multiple regression is now, after we run the multiple regression, we want to see the betas and whether the betas are significant. So how many betas will we have when we run a multiple regression with this model? Okay, we will have 2 betas because we have 2 predictors. Happiness is the outcome. This social support is a predictor, and time with friends is a predictor. Those are 2 separate predictors, and so we're going to have 2 separate beta weights. Specifically, we'll have a beta weight here, and we'll have a separate one here. Meaning, there'll be a beta weight saying, what is the effect of social support on happiness independent of time with friends? And a separate one that says, what is the effect of time with friends on happiness independent of social support? If time with friends causes social support and social support causes happiness, which beta weights should be significant? Only this beta weight should be significant. This one we do not want to be significant. Now, why would that be? Because what we're saying is that social support is the thing that actually causes the happiness. Time with friends just causes the social support, just changes the social support. It doesn't affect happiness by itself. When the beta weight is not significant between time with friends and happiness, that's exactly what it's saying. When you take out the effect of social support, time with friends cannot predict happiness. However, time with friends does predict social support. We already saw that when we got the Pearson's R that was significant. And social support by itself does predict happiness. That's if the beta weight is still significant. So in mediation analysis, the first step is run a Pearson's R with everything, and they should all be significant. The second step is run a multiple regression. The mediator, which is social support, so this is the mediator, the one in the middle, the one that is mediating things. The mediator should have a significant beta on the outcome. But the first predictor, in this case time with friends, should not have a significant beta with the outcome. Okay, that should do us for the rest of this chapter. We're going to talk more about moderation when we get to more with experiments.